Hey there, sixth graders. In this video here today, we're going to go through what you're going to work on in class today and then do some notes and again give you some instructions for your graphic organizer. So, the order of class today, as you're watching this video, step one is going to be to take notes. Step two is to watch an Ed puzzle and complete the Ed puzzle. It will be for a grade. Step three is to work on the graphic organizer, which is a Google drawing found in Google Classroom. And I'm going to go through the directions for that after the notes. So the very first thing you need to do is open up your class notes document for plate boundaries. If you need to pause the video right now to get yourself set, go ahead, pause the video now, and then come back to the video here as we'll go through this one slide, which is the last slide of notes for you. Okay, let me move myself there. Okay. We are talking about hotspots. And yesterday in class, we watched a little bit of that video from Iceland and learned that there is a hotspot underneath Iceland as well, besides it just being on the mid Atlantic ridge. But there are other hotspots in the world that are not near a plate boundary. So, by definition, as it says there, a hotspot is an area of volcanic activity that's usually in the middle of a plate, not close to a boundary, Iceland being the exception. Area of volcanic activity usually in the middle of a plate, not close to a plate boundary. Okay, sub-bullet. This is an important thing to remember. The hotspot does not move. The hotspot does not move. It is stationary, and the plate moves over the hotspot. So if this hand here, if this is the hotspot, if this is the plume of that hot rock and maybe even magma, and this is the plate literally will move over slowly, obviously, because plates move slow, over the hotspot. So what this does then is that if that hot spot has been there long enough, it literally can create a chain of volcanic eruptions or mountains on an island. What's going to be unique, though, is that not all of those volcanoes might be active at the same time. It's only the volcanoes that are still underneath the hot spot. Because remember, the plate is moving above the hot spot. The hot spot does not move. So if it moves off of the hot spot, that volcano is no longer active. So geologists can use this to kind of get some estimated age of the islands and the motion of the plates and all these other things. So the eruptions get older as they get farther away from the hot spot, okay? And that obviously is relative to the direction in which the plate is moving. Eruptions get older as they get farther away from the hot spot. All right, so if we look at this bottom diagram here, the Hawaiian Islands. Hawaii formed from a hot spot. The arrow is showing the direction of the plate movement, and here's the hot spot. If this is the hot spot, this is the newest island. The furthest one away, all the way over here, is the oldest. Second oldest, this one. Second youngest. Eventually, the big island of Hawaii here that's on the hot spot is going to be over here. It won't be on the hot spot anymore. Won't have active volcanoes anymore, and a new island will form. So there you go. If you're looking to make big bucks one day, you should start buying the land that isn't even there yet. It'll be there eventually in a few million years. Get in now. Make lots of money. Buy the next future island of Hawaii. All right. Hawaii is our main example. and we're actually going to do a whole activity where we focus mostly on Hawaii here on Thursday and Friday. It'll talk a little bit about Yellowstone. We've already talked about Iceland in that video. The Galapagos Islands also formed because of a hot spot. They are not at a plate boundary. The Philippines, Japan, all of those, they're on plate boundaries. So those are volcanic islands formed because of the convergent boundary. All of these examples, Yellowstone, Iceland, Galapagos Islands, Hawaii, they're not at a plate boundary. So it's literally the hot spot is why the land is up above the surface of the water. Okay. Once you have that, you can close that tab. And let's talk about the graphic organizer so that you can then turn the video off. But don't forget, the other thing that I want you to do after your notes, or I should say the next thing after the notes, is to go to Edpuzzle to do the Edpuzzle. After the Edpuzzle, then you're going to work on this graphic organizer, but I want to go through the directions with you one more time. I did it yesterday in class. Not everybody was here, or maybe you need a refresher real quick. So here in Google Classroom, plate boundary, web. Okay, it looks like this. Let me zoom in so we can pay attention. Right, it's a web with plate boundaries being the main idea. Then you have your three types of boundaries: transform, divergent, and convergent. Divergent and transform are the easy ones. They were just one slide of notes, and you're going to use your notes to be able to find all this information. It's all in your notes. So divergent boundary, you have these three boxes, and those three boxes just keep getting repeated for all the different boundaries. The three boxes include: how do the plates move? So are they moving towards, away, sliding past? Is there subduction? All of that can go in there for how the plates move. Geologic activity. What is the geologic activity? I usually have that listed in your notes. Are there landforms like ridges or mountains or volcanoes or trenches or rift valleys? Are there earthquakes? All of those are examples of geologic activity. The last box is examples. So give me some examples on the planet of where these landforms or this geologic activity takes place. So if it's a mid-ocean ridge, you can mention the mid-Atlantic ridge. You can, if it's a mountain, you can talk about the Himalayas or the Rocky Mountains. So you're going to give me examples. Again, all in your notes. Use your notes. So like I said, divergent and transform are easy. One slide each. Convergent here at the bottom, there's a lot more because there are three types of convergent boundaries. And so you'll have to start by putting those three different types of convergent boundaries in there. The different boundaries are because of the different plates, the different crust. So oceanic to oceanic, for example, is one of them. Use your notes to find the other ones. For each of those types of convergent boundaries, you have those three boxes here then again. Examples: how do the plates move? Make sure you talk about subduction, and then the geologic activity. Okay? All right. You are working on this. You have the Edpuzzle to do before you do this, and then you're working on this. If you finish all of that and there's still class time, which I doubt because it's Wednesday, it's short, I'm going to also have a link in there just for a video to watch about the Ring of Fire, but you don't have to get to it if you don't. All right, have a good day. I will be back tomorrow. Get working. This is all independent work today. Independent work today. Okay? All right, get your work done.